Alright, so here's the integral that we have to solve. So how should we go about doing this? Well, as always, if I'm gonna first real quick outline the ways we can try to attack this problem. We can try we can try by substitution. We can try then well, this is u-substitution, okay, and then we can try trig substitution, and we can try integration by parts. Okay, so generally speaking, I always try to see if I can get away with the u-substitution, because that's generally the easiest thing in my experience to try if it works. But I get the sense that we're out of luck in this problem, because for u-substitution you want a function in the form of in something that looks like this. So something that looks like the integral of some function f of x times the derivative of f of x dx, right? So that way, when you this is not, I don't see that here, right? So because, for example, if we let u equals 5x plus 2, then du equals 5 dx. Okay, but we have this x out here. If it was such that when we differentiated this, we got 5x out here, then we would have been fine, right? Or 10x. Like, for example, if this was 5x squared, right, then this would be 5x squared, and du would be 10x dx, right? Then du over 10 equals x dx, right? And then we can just we could have just substituted du in here, and we'd be off to the races. But since this is not the case, we're just gonna backtrack, right? So since this is what we have, this is not gonna work, right? So this is nope. So this is by u subs. Okay, so that's not gonna work. So let's try by parts, because we know trig substitution is not gonna work, because for trig substitution we need, if you see something like x squared plus 1 or x squared plus 9, that's a good indication that trigonometric substitution could work, because this is the square of something plus the square of something, right? And that's equal to the square of something else, because we have for a squared plus b squared equals c squared when we have a right triangle like this, right? So c a b, right? Okay, so let's just try by parts. Okay, okay. So what's the first step? Well, let's just recall what the integration by parts formula looks like. So if you have a function of the form f of x g prime of x equals f of x g of x, then if you have in this form, then the integral is given by f of x g of x times f prime of x g of x. Okay, and this is derived from the product rule of differentiation, but I'm not going to go into that right now. So the play here is to figure out in this function, I should probably erase this because that's okay. Alright, so the play here is to figure out which parts of this function should be f of x and which parts should be g of x. Okay, so we need f of x, and we need g prime of x. Sorry, I meant g prime of x earlier. Okay, and then from this we need to get f prime of x, because we need that here, and we need g of x, because we need that here and here, right? Okay, so now which should be f of x, which should be g prime of x in this equation, in this function, sorry. And that's honestly just a matter of practice, but the idea is that if you can, you just gotta keep in mind that you have to integrate whatever you get here, right? So if this makes it, if your selection for this f of x makes this integration complicated, maybe you should try to avoid that. Matter of practice, right? So in this case, I'm just going to go ahead and let f of x equals x, right? So that equals x, and let g prime of x equals e to the 5x plus 2. Okay, so differentiating this is pretty straightforward, and on the plus side, this becomes a constant, which makes this whole thing much simpler, right? So f prime of x for f of x equals x is just 1, right? And the integral of this is not that difficult either, right? So this g of x is the integral of e to the 5x plus 2 dx, and we can simply do this by using u substitution. So we'll let u equals 5x plus 2, right? And then du equals 5. Okay, this goes to 0, this becomes 1, 5 dx. Okay, and then du over 5 equals dx. Then we just substitute this back in. We get, this is the integral of e to the u du over 5, right? Which is just, so you bring the 1/5 outside, and the integral of e to the u is just e to the u, so this is just 1/5 times e to the u, and then you bring this back in, you get e to the 5x plus 2 over 5. Okay, so that's g of x. Okay, and so now we sort of have all of our components. So let's just bring this back up here to make more space. So the integral of x e to the 5x plus 2 dx equals f of x times g of x, so that's just x times g of x is this thing, x times e to the 5x plus 2 over 5, that, okay, minus the integral of f prime of x, which is just 1, thankfully, right? And then that's that whole thing times g of x, which is again e to the 5x plus 2 over 5, right? So now we can just pull this 1 over 5 outside. That just gives us x e to the 5x plus 2 over 5 minus the minus 1/5 times the integral of e to the 5x plus 2 dx. Okay, and we already did this integration, right? It's the exact same thing. So it's just going to be, this is the answer. So this is just going to be x e to the 5x plus 2 over 5 minus 1/5 times this. So e to the 5x plus 2 over 5, right? So you can just simplify this out. We get x e to the 5x plus 2 over 5 minus e to the 5x plus 2 over 25. And you can pull this out and do some more simplification, but essentially this is the answer. Okay.